Our next speaker has 16 years of experience in direct view LED technology with a focus on high-end display performance, especially in studio and critical environments. For color management and direct view LED displays, please welcome the Chief Technology Officer of Naoti, Aaron Kipfer. You want to use this one? That seems good.
Did you know that viewers make up their minds about what they're viewing within 90 seconds of what they're actually seeing, that initial interaction? And within that 90 seconds, up to 90% of what they're viewing and the decision that they're making of that viewing is made up and influenced by color. So that's what we're here to talk about today, is color management in direct view LEDs, why it's important and why it's so difficult. So as mentioned, my name is Aaron Kipfer. I'm with a company called Naoti. We manufacture direct view LEDs for broadcast environments, for studio environments, for corporate applications, and many others. We've been around since 2006 with direct view LED. Started as a digital signage company, morphed into LED for manufacturing purposes because we weren't happy with the type of LED that we were seeing in the market and wanted to do something about it. This is just a few of our customers that we work with on a regular basis. As I mentioned, we specialize in broadcast and virtual environments. So many of the ABCs, NBCs, affiliates, broadcast studios, including two of them here in LA, are using our LED displays as on-camera performance for backdrops, for desks, for all kinds of applications. But as we talk about color for LED, obviously color is important. As most LED manufacturers are racing to get to the highest resolution possible, we've started to ask ourselves, why is that important? All that means is that you can get closer to the LED display and view it from a closer distance. But what's on the LED display is more important than what you're actually seeing as far as the resolution goes. And so whether it's an 8K wall or a 4K wall or a 2K wall, it should matter what is actually being viewed on that display. And so as we look at the top brands of the world, color matters because all of these brands that you see here, whether it's Coca-Cola, T-Mobile, John Deere, they've all taken painstaking efforts to either make specific color profiles, sometimes to trademark those color profiles so that those colors are meant to be viewed and recognized as their brand. So when we put those on LED displays, they need to be accurate. And why is that difficult? So in most LED displays, you see on the bottom image here. You see saturated images. You see images that aren't necessarily true to life versus the top image is more of what your eye actually sees. And so when you're viewing LED, whether it's in a movie studio or whether it's at home or in a corporate environment, maybe even a Coca-Cola lobby, you want to make sure that you're seeing colors accurately represented, especially when it comes to skin tones. So skin tones are notoriously difficult for direct view LED to reproduce because direct view LEDs and skin tones, the red in direct view LED actually makes it more difficult, and because it emits more light than the blue and the green, or if you have amber or cyan or any of the other colors that are part of the diode itself, the red is always hot. And so when you're looking at skin tones, you might see on a direct view LED screen something like the image on the left, where her skin tone is much more red than what it would be in real life. And versus the image on the right, it's more of a clear image. And especially when you're dealing with skin tones in broadcast environments or you're seeing Zoom calls, things like that are being shown on a direct view LED display, then you want to make sure that that's an accurate representation of the person on the display. So the challenges for this are myriad. So the first challenge is always making sure that you're using the correct components. So when you're looking at manufacturers, you want to make sure that they're producing product that is manufactured correctly and manufactured with high quality components that can give you the performance that you need out of the individual pixels that are on the LED screen, much different than what you're working with on an LCD display or much different than you're working on a regular TV, because with direct view LED, you're dealing with individual pixels that are controlled by a control system. So it's a little bit of a different technology. So the quality of the manufacturing, the quality of the individual diodes, the IC drivers, all of the parts and pieces behind the boards make up whether or not you can be accurate with your color representation. Ambient lighting in the room, ambient temperature in the room, all has an effect on how color is produced because it changes the properties of the colors that are being displayed. Calibration capabilities, again, you can kind of see in this bottom image here the different levels of calibration all within a single LED display. So if you walked around an airport or other environments and you look at LED displays that have been there for a while, you start to see a lot of separation between different small sections of the screen or modules. And also things like UV exposure. And most importantly, the control system that's used to drive the LED display. It's not all built into one simple display like a TV. You're working with multiple cabinets, multiple modules, hundreds of points of failure versus in a TV environment or a projector environment, you're only dealing with 1 or 2 points of failure. And so you have to have a control system that can perform and control the individual RGB pixels in a way that produces those accurate results. So one of the biggest challenges is, as I mentioned, with calibration. So over time, your LED display degrades as it's running and running and running. And so over a year or two, you start to see displays that look like this, whether you're in Vegas or, as I mentioned, airports, where different modules, because it is a modular system, can be removed and replaced with spare parts and things of that nature. But as you do that, you're replacing spare parts that may have never seen the light of day or may have never have any runtime hours on them into a display that maybe have been running for a couple years. And so you end up with calibration issues in your white balancing, which makes for, over time, a poor display performance. And then you have technologies like SMD or COB. SMD are individual pixels that are in the manufacturing process calibrated so that each individual RGB pixel is binned and batched so that when you create a display that it's mostly calibrated to begin with, versus a COB product, you're doing that at a modular level, much like what you see in this image. And so if you can't produce a display that can be calibrated by a camera to be seamless, to look like this, you're typically doing that with a COB display because COB displays have to be done at the modular level. So calibration is much more difficult with COB, but it's becoming more popular because it's an easier and cheaper method of manufacturing. And then other things like white balance calibration. I mentioned when you are in an environment where you have a lot of ambient lighting, such as a room like this, if it's not the same temperature as the LED wall, then you're going to be modifying a little bit the LED performance and the LED color that's being shown. And so also when you're looking at it through a camera lens, you're also looking at it in a different color temperature because of the camera is seeing it differently than your naked eye. So in this example here, the backdrop is much more amber colored, and that's the LED wall looking at it with your naked eye, versus the camera monitor that you see, the preview monitor, is seeing it in much more blue than what it actually is in person. And so you have to take all those things into account to make sure that you're producing an LED display that can perform no matter what you're pointing at it. And then grayscale performance obviously makes a big difference when it comes to seeing the image how it's intended to be seen. So as in the top image, if you see in the darker area, you can see that there's some imagery there. There's some detail there that you don't see in the bottom image. And that's because in the top image, you're getting a lot of performance out of that LED so that you can see the fine details even in the lower bright areas, where if you have really poor grayscale levels, it just disappears. You lose a lot of the details. So when you're working with things like darker images or your darker productions, where there's a lot of dark grays, a lot of dark areas of the display, you want to make sure that you're choosing a performing LED that has that capability, that can show those dark areas and not just have them disappear. Same thing with gamma, and making sure that your gamma point doesn't change as your brightness level changes. So a notorious thing for LED is that you can calibrate an LED screen for any level of performance, but as soon as you change any aspect of that LED, whether it's the brightness of the LED, then you lose a lot of that. Your grays and your reds and your blues all start to shift from their original color points. So you want to make sure that you can control that. One way that we've done that at Neoti, and you can see this, I won't go into a ton of detail, but we have a booth over here. One way that we've done that is we launched this year the world's first Pantone validated direct view LED display. What that means for everyone is that even if you don't know who Pantone is, what it means is that we can produce accurate colors at any level brightness with our LED displays in true to life imagery. So we're not modifying the image signal at all. So if you give us a specific color profile, that color profile is automatically detected by our control system because we manufacture the control system. And then it also then is faithfully reproduced on the LED screen because we manufacture the LED screen. So we take a holistic approach versus most manufacturing of LED is using a third-party control system married to a direct view LED display panel. And when you do that, then you have two competing companies that are beholden to the timelines of each individual company on what they want to produce and what features and functionality they want to perform. We decided we wanted to take a holistic approach by manufacturing the entire system from soup to nuts to make sure that we could get the performance out of the LED display that we wanted. And so while no one else has been able to get Pantone validated with a direct view LED display, we have been able to do that because of this approach. And what that means is that whether or not you care about Pantone, it means that we can accurately reproduce colors because Pantone has a book of thousands of colors, hundreds of skin tones, and being able to test each and every one of those in their testing facility is how they validate whether or not that you can perform well. And we were able to produce all of those colors accurately to match if Coca-Cola has their Pantone color or if T-Mobile has their Pantone color on our LED display, it's going to be the exact same color as if they have it printed with a Pantone validated printer. And so our UHD Pro XF Plus series is built with high quality components, which is what we talked about at the beginning. It is a holistic approach, so it takes into account the LED and the control system. We can actually color profile match. We can color profile match. So if you have a specific color profile that you want to use, or if you have a custom profile that you want to use, we can actually match that 100% without doing any image manipulation. We just take your profile in, the control system recognizes it, changes the properties on the LED screen to match, and you're good to go. So we don't manipulate the source at all. Most of our products can go up to 240 hertz for high speed action shots, things of that nature. Especially when you're starting to work with virtual studios, in those kind of applications, you want to make sure that your motion isn't blurred and those types of things. And then most importantly, we have fully automatic white balancing. So this means that if you pull a module from a display, as we were talking about before, and that module has never seen the light of day, and you're putting it into a display as a spare or something to fix a problem, that module will automatically heal itself or automatically white balance itself without any human interaction, without any camera interaction, without getting into any software. It automatically does it because our system, over the entirety of the display's lifetime, is constantly looking at the properties of that display. All of the data points that we collect are put into our systems and into our algorithms, and the intelligence built into our system is allowing that display to constantly monitor, is this module performing correctly as the rest of the display or not? To the effect that we also have automatic thermal compensation. So if you have a really large LED display in a volume environment, and say you have an air handler that's pushing cold air to one side of the display and the other side is not, the color properties of that LED display are going to be slightly different because a cooler display runs cooler. It runs more blue than a warm display, which runs more red. So when that happens, you have to have something that's smart enough to know the difference between this side of the screen and that side of the screen. And so our system not only manages the white balance, but it does it also from a thermal property and makes sure that from a thermal compensation property that screen stays balanced throughout the entirety of the screen, throughout the lifetime of the display. One of the ways that we were able to accomplish this is we worked really closely with Porsche in Germany, where our control system and entire system is made. So it is TAA compliant, which is a side note, not necessarily important for this crowd, but it is a TAA compliant product, so it could be used in government facilities, Department of Defense facilities, and other areas where you're using secure environments. But we worked with Porsche and their design center to develop a control system and an LED system that would allow them to visualize what they're designing in a highly critical environment to make sure that they're seeing the paint colors, the leather swatches, the finishes that are within their vehicles in a way that allows it to show 100% true to life accuracy. So as you see in this image here, this is just a snapshot of what we were actually doing in their facility. So you have a light booth on the left-hand side with actual painted model cars in a controlled environment with, the specific lighting in the light box. We have to the right of that on the bottom, we have calibrated monitors that they were using to visualize what was happening from the camera. And then in the background, we have our LED display, which was allowing them to have perfect, if you were to put a color meter on it, have perfect XY values across all three devices. And so that, again, is what we are passionate about, is making sure that color is performing the way that it should be and that you're not seeing artificial coloring in direct view LED. On top of that, we have HDR10. We can do PQ, HLG. We can do 3D. That's a misprint. It's 3D at 240 hertz with some of our product as well, which keeps you from having eye fatigue when you're using 3D active glasses. And again, all of this matters because when you're in a volume studio or when you're in an environment where you're running a lot of cameras or you're running a lot of content on the display, especially in a studio environment, this reduces the time that you need in post because you're already running everything as accurately as possible. You're running it as accurately as the creators intended it to be viewed without having to do any kind of modification. You just plug it in and it's good to go. So as I mentioned, we have a booth over here. Feel free to stop by anytime. We can talk.
Solutions Hub. Lunch will be served at 1:15.